All right. I believe we are live. Great. I think we're live. Chloe, welcome. You're first. Welcome. Nice to see a familiar name in the chat. Welcome back. Really excited for today's lesson. I don't remember, Chloe, if you've been to grade 6 through 8 math lesson before, but let me know if you have. Hi, George. Welcome. I see Raymond is in the chat as well. Welcome, everyone. If you can hear me, put a plus in the chat. I don't know if you can hear me yet. Hopefully you can hear me. I totally forgot to check that first. Hope my mic sounds okay. But welcome back if you can hear me. Awesome, Chloe. Thank you for the pluses. Love the enthusiasm. Love it. Welcome back, Chloe and George. All right. Well, today you are in the right place if you're here for grade 6 through 8 math. We're talking about multiplying and dividing fractions. If I hear you loud and clear, amazing, George. I hope you have heard about this lesson before, or if you haven't, you're going to be master at it by the end of today's lesson. Really excited to show you what I have planned for you today. But before we begin, let me introduce myself. I'm Eddie Kang. I'm the senior math teacher at MyEdSpace. I've been teaching for 9 years in high schools and colleges. I've tutored every level from 6th grade math all the way up to students preparing for graduate school. So I've really done it all. I did really well in school myself. I got A's in all my math classes, got a perfect score on the SAT, and yeah, got into my dream school, UCLA. After graduating from UCLA with a bachelor's in pure mathematics, yes, I'm a nerd, I found that I love teaching math more than I loved math, which was pretty crazy to me. All my students have gotten to the top universities. They've gotten exceeded the standard on state exams, entrance exams, the SAT, the ACT. They've gotten 5s on their AP exams, but most importantly, they had fun doing it. Fernie, welcome. They had fun doing it, and that's what I'm here to show you today. I want you to have fun learning math, right? My job is to make math fun and approachable, to make you the next generation of math geniuses. But before we begin the fun today, if you could do me a huge favor, copy that link at the top of your browser, copy that URL, share it with your friends, share it with your group chats, send them all into today's chat. Let's have fun all together. So I'll give you a couple seconds to do that. Copy that link, share, press share, copy link, share it to your group chats, your friends, whoever. Let them join on in today, and let's have some fun. All right, let's get started. I love starting my lessons with a vibe check. A vibe check is just to get your brains reactivated, because when we usually meet at 5 p.m. Pacific time, you might be really tired from your extracurricular activities, maybe from school, the long ride home, whatever it may be. I just want to get your gears activated again and your brain working again. So something fun, something light, but that still has something to do with our lesson today. So which one of these types of 4 chocolates is your favorite type of chocolate? A looks kind of like those bars that you can break apart, kind of like Hershey's. B looks like M&M's, maybe just like smaller chocolate candies. C looks like Kit Kats, maybe with wafers in them. And D kind of looks like Snicker bars or Twix or anything like that. So A, B, C, or D in the chat. I see Chloe, you're already there with C. Max agrees with C. Welcome, Max. Nice to see you. A, B, C, or D. If I were to say which one is my favorite, when I was younger, I definitely liked those mini M&Ms in the plastic bottles. I used to love those. So I would have had to go with B. But right now, if I had to choose one, I think it would have to be C. I'd have to agree with you all in the chat here. It would have to be C. If anyone likes anything else, make sure to put it in the chat. But all of these, if you look at these, all of these can be used as fractions, to explain fractions, right? In part A, these chocolate bars could be split up into different pieces. Yeah, honestly, Chloe, I love chocolate as well. I would choose them all, right? B, it looks like in a plastic bottle with a whole bunch of maybe marbles or M&Ms, right? A fraction of those. C as well, you can split them up. And D as well, you can always split them up. A whole piece into smaller pieces. So that's what we're talking about today. Fractions, multiplying and dividing fractions. Really excited to show you all today. Before we start every lesson, I love to start with something called an APK. It's accessing your prior knowledge so that you are able to access everything in the lesson and not feel lost, right? I have very many re-entry points in a lesson to get you back in if it ever gets too challenging for you. So that's why I love starting with this APK. And today our APK is on improper fractions and mixed numbers. So let's start. An improper fraction, let's see what it is one where the numerator is greater than the denominator. So let me explain this to you really quick. A fraction, if you thought of a whole split into thirds, we would say, all right, how much of the whole do you want, right? Right now it's split into thirds. Let's say you want one part of those three parts in the whole. So you'd say 1/3. And now if you wanted two of those pieces, you'd say, I want 2/3 of that. If you wanted all of them, you'd say, give me all three pieces. But once the numerator becomes greater than the denominator, notice how there's only one, let's call it a cake. There's only one cake with 3 pieces. How can you get 4 pieces? So that's where the term improper came from. And so an improper fraction is whenever the numerator is greater than the denominator. Now, a mixed number, or let's do a really quick test here. Can you give me an example of an improper fraction in the chat? Just any improper fraction you could think of right now, just really quick. Give me an example of an improper fraction, just like what we wrote here. Right now, my example of an improper fraction was 4/3. What would your example of an improper fraction be? Let me know in the chat. Max, 7/4, that's a beautiful improper fraction. 7/4. 7 is the numerator, 4 is the denominator. 7 is greater than 4. Chloe, amazing. 7/6, right? Still 7, the numerator is greater than the denominator. Perfect. I'm glad we got it. So those are improper fractions. Now, a mixed number is when we have a whole number attached to a fraction where the numerator is still smaller than the denominator. So let's use these 3 examples from me, Max, and Chloe to create mixed numbers that are the same, that are equivalent to these improper fractions. So let's start with my example, 4/3, and let's see if you can get your own improper fractions into mixed number form. So 4/3, it looks like 3 goes into 4 once. So I'm going to put a 1 in front, and how much is left? Well, if I put 3 into 4, then I'm left with 1. So I have 1/3. This is an example of a mixed number, right? 4/3 means there's one whole in it with an extra 1/3. So using Max's example of 7/4, what would you say would be the mixed number respective or equivalent to 7/4 in the chat? Name me the mixed number that's equivalent to the improper fraction 7/4 in the chat. Max gave us this beautiful improper fraction 7/4, and I'm looking for a mixed number. I know 4 goes into 7 fully at least once, not quite twice, right? Because 4 times 2 would be 8, which is now greater than 7. Chloe, I see you got it already. 4 goes into 7 once fully, and then we're left with 3, right? 3 out of 4. So again, back to our description of a mixed number, our definition of a mixed number. A whole number attached to a fraction where the numerator is smaller than the denominator. Notice how the numerator 3 is smaller than the denominator of 4, so this makes it a mixed number. All right, Chloe, your example, 7 out of 6, 7/6. How would we write this one as a mixed number? Given that we have an improper fraction 7/6, we know that 6 goes into 7 fully once, and how many are left after that? 1 and 1/6. Chloe, you're number 1 in the chat right now. Beautiful work. We have 1 and 1/6. Awesome. Notice how our denominators stay the same, and the only thing that's changing here are our whole numbers in front of the mixed number and our numerators. Great stuff, Chloe. Easy peasy, right? Great start. Now, write each situation as a mixed number and improper fraction. Let's do that. So for this first one in the darker blue, what would the mixed number be for this first example in darker blue? We have one example in darker blue on top and a second example in lighter blue on the bottom. For this first one, how would you write this as a mixed number? As a mixed number. How would you write it as a mixed number? It looks like we have 2 total. Max, amazing work. Chloe, right behind you. 2 and 3/4. Awesome, right? We have 2 full circles and then 3/4 of the next one. You know what? Might as well do the next one as well. Let's try this one as well. How would you write that one as a mixed number? Right, this one's going to take you a little bit more time to count, so I'll wait a couple more seconds. But it looks like we have, for sure, 1, 2, and 3 full ones. So we know there's going to be a 3 in front. And it looks like each circle is split up into 8 pieces. 1, 2, 3, 4, 5, 6, 7, 8 pieces. And it looks like we have 1, 2, 3, 4, 5 pieces in this very last one. Awesome, Max and Chloe. Both of you got that 3 right there. And then with 5 eighths next. Awesome, Chloe. 4th, 6th. Pretty close. If I mean, you probably just counted. Yeah, you probably thought it was 6 pieces. All good. But reminder, Chloe, you've been here before, so you know what I'm going to say. I love when you make mistakes. I love when my students make mistakes, because when you fix those mistakes, that's when you're truly learning and retaining the skills, concepts, and material. So I love that you made a mistake and you fixed it, right? So we're really learning here. Amazing work. Now, with mixed numbers, I can convert them into improper fractions. Let's think about how we can do that. Well, without having to count everything, 2 full 4s would give us how many, right? 2 full 4s would be 2 times 4 plus the 3. Nice try, Chloe. Yes, absolutely. I love that we're all trying here, right? That's what's important. That's the hardest part about math. 50% of the game is taking that first step and trying, right? Amazing. So we have 2 times 4 is 8, plus 3 will give us 11/4. And let's check. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we have 11 of the 4 parts. Amazing. So if we were to do this one, what would 3 and 5/8 be in the form of an improper fraction? What would 3 and 5/8 be in the form of an improper fraction? In the chat, what would you get? We just found that if we have 2 full 4s, we multiply the 2 times 4 to get 8, plus the 3 to get 11 all over 4. Chloe said, I'm not going to get this one wrong. My head's in the game. Chloe, you are locked in. Let's go. We have 3 full 8s. So we have 3 times 8 plus the 5 all over an 8. Well, 3 times 8 is 24, plus the 5 gives us 29 over 8. Chloe, amazing work. I love the growth you're already showing, and we're not even halfway through this lesson. Great work. Max, I'm sure you got it as well. 3 times 8 is 24, plus 5, sir. Yes, that's correct. 3 times 4 is 24, plus 5 is 29. Amazing. Nice job, Chloe. Yes. All right, let's keep this ball rolling. Now, we know how to change from mixed numbers to improper fractions. We're going to need that skill later on. That's why we just covered it as our APK. Let's go into multiplying fractions. Imagine you have a chocolate bar. So back to our vibe check. Love that, right? Let's say this chocolate bar is broken into 2 equal pieces, and you have one of those pieces. We can call this half of the chocolate bar. Now, pretend you want to share your piece with your best friend, right? You decide to split that in half and give them one of those halves. So you're sharing half of your half. Okay, stay with me here. So in total, if you look at this red box down here, this is how much you've shared with your best friend. When you share half of your already halved chocolate, you are not giving all of it away, right? Just some of them. When we talk about multiplying fractions, we're talking about sharing a part of something. With our chocolate bar, you first took half. That's the first half. Then from your half, you shared half again. That's the second half. This means you shared half of your half. So if you take half of a half, you have 1 out of 4 parts of the whole chocolate bar. That's why we say 1/2 times 1/2 is 1/4. And that's where we get the pattern, right? That's where we get the pattern. If we have 1/2, a fraction, times another fraction, notice how we just multiplied the numerators and multiplied the denominators to get our final answer of 1/4, right? 1 times 1 is 1, and 2 times 2 is 4. So let's take a look at this as a pattern. To multiply fractions, we simply multiply the numerators and denominators. And the first thing I'm going to do here is I'm going to say, let's put this all under one division bar. And reminder, when we have a fraction, it's the same thing as division, right? The bar in the middle of the numerator and denominator, we call it a division bar because what we're actually doing is dividing. So let's rewrite this. We can rewrite this expression as under one division bar, 3 times 5 over 7 times 8. Really quick in the chat, let me know what you get in the numerator. What's 3 times 5? Speed test. 3 times 5, what do we get? And right after that, give me 7 times 8. Might as well. 3 times 5 in the chat. We got Chloe in first. We got 15. Amazing. And then in the numerator, we got 56 right off the bat. Amazing work, Chloe. Love to see it. Now, between 15 and 56, are there any common factors that we can divide? In other words, cancel. Well, if we look back to what we did, 3, 5 have nothing in common with 7 and 8. So that's our fully simplified form. Max, I see you. 56. Amazing work. Let's try this next one. We have 4 times 7. Let me know what that is in the chat. And then 9 times 11 in the denominator. All good, Max. Love that you're sharing this stream with your friends. Hopefully that's why you're looking at your messages. But we have 4 times 7 in the numerator, 9 times 11 in the denominator. What we got for that? Chloe, you're too quick for me here. 4 times 7 is indeed 28, and 9 times 11 is 99. Awesome work. Let's try this last one together. We have 2 times 3 and 5 times 8. Max, I see you are locked in as well. We got 28. Give me this as a fraction this time. Yes, mental math, mental arithmetic. We love it. Give me this one as a full fraction this time. Instead of giving it to me separately, give it to me as a fraction. We have 2 times 3 in the numerator and 5 times 8 in the denominator. Wow, Chloe, you're answering before I even ask anymore. That's amazing work. We're thinking ahead. Love to see it. Let's see if Max gets the same thing here. We have 2 times 3, 5 times 8. If you're scared to chat, don't worry. Please chat. Just say hi. Just, you can say the same answer. Chat it up, right? Get comfortable. Don't be shy. Participate. We have 2 times 3 is 6. 5 times 8 is 40. Now, what do you notice about this one, y'all? We have 6 in the numerator, 40 in the denominator. And remember, the division bar represents division. So whenever we have the same factor, or whenever we have common factors at the top and the bottom of the fraction, we can cancel them out. What do you notice about this one? Hi, if you're new, Chloe. I love how you're being friendly. I love it. 6 and 40. What number are they both divisible by? 6 and 40, I know they are both even. So if they're both even, then I know they'll be divisible by what number? Even numbers are always divisible by 3 over 20. Okay, Chloe, you got to the answer. How did we get there? You're correct, by the way. 3 over 20. How did we get there? By 2. Yes, we can divide both the numerator and denominator by 2. So we divide by 2 to get 3, and we divide 40 by 2 to get 20. And now 3 and 20 don't have any more common factors, and that's how we have a fully simplified fraction for this problem. Great work, everyone. Now, here's what it is. As we saw in the last part of the previous example, we could simplify the last fraction further, right? We were able to cancel. But we could have addressed this before we had even multiplied the numerator and denominators together. We know that 2 times 3 is the same as 3 times 2, and we can use this idea when multiplying fractions. Let's look at this again. What we said, all right, 2 times 3, 5 times 8, and we said 6 over 40, and then we canceled the top and bottom to get 3 over 20. Now let's do this again, except cancel the common factors before multiplying across. We know that 2 times 3 is the same as 3 times 2. So after we rewrite this under one division bar, we can rewrite 2 times 3 as 3 times 2. And now look what happens. 2 and 8 are now right over each other. So 2 and 8 have a common factor of 2, so we can cancel that out first. 2 divided by 2 is 1, 8 divided by 2 is 4, and then we can multiply across. Exactly, Chloe. 2 and 8 become 1 and 4. Beautiful. 3 times 1 is 3, 5 times 4 is 20, And now, why is this useful? Right now, we're using smaller numbers, right? Right now, we're using smaller numbers. But later, when the numbers get much bigger, much larger, this will become so useful so that our numbers that we're multiplying don't get too big. And we're going to see some examples of that right now. Simplify the following. Let's rewrite this. 5 times 8 all over 12 times 15. 100. Yes, love the emojis. This will equal, well, 5 and 12 have nothing in common. 8 and 15 have nothing in common. But I know from our previous slide, I can rewrite 5 times 8 as 8 times 5, all over 12 times 15. Now let's take a look. 8 and 12. What is a common factor that we can cancel from both 8 and 12? We know that 8 and 12 are both even, so we know that they'll both be divisible by 2 again, right? We know that both 8 and 12 will be divisible by 2 once more. So 8 divided by 2 will give us 4. Oh, all right, Max and Chloe, you're ahead of the game. Let's do that instead. Love that. 8 and 12 are both divisible by 4, right? Let's jump it up a level. All right. 8 divided by 4 is 2. 12 divided by 4 is 3. Amazing. 2 and 3, they don't have anything in common, so we're done there. How about with 5 and 15? What can we do with 5 and 15? Wow, Max is number 1 now. Let's go. I see this friendly competition. We love friendly competition, by the way. It makes everyone better. Yes, 5 and 15, both divisible by 5. Great, Max. Great, Chloe. 5 divided by 5 is 1. 15 divided by 5 is 3. And now we multiply across. And what do we get as our fraction? What's our final fraction here going to be? If we multiply straight across the numerator, straight across the denominator, now that we have simplified everything we could before actually multiplying the bigger numbers, what do we get? Chloe was faster this time, 2 over 9. Beautiful work. That is our final answer. Now let's try part B, letter B. We have 12, great Max, 12 times 35 all over 21 times 16. Now, 12 and 21 actually have a common factor. Can you tell me what that common factor is? 12 and 21. What are they both divisible by? 12 and 21. And I want to do this before flipping the multiplication in the numerator, right? Because I recognize that 12 and 21 already have some common factor. Yes, Chloe, 3. 12 divided by 3 is 4, and 21 divided by 3 is 7. And now, 4 and 7. Yes, Chloe, 4 and 7. But, 4 and 7 don't have anything in common. So now let's try changing the order of 4 times 35 and saying 35 times 4 all over 7 times 16. Now take a look. Yeah, that was really fast, right, Max? We got to lock in. 35 and 7. What do these have in common? What do 35 and 7 have in common here? 35 and 7. Love that. Love the friendly competition. We love that. 35 and 7 have a common factor of, yes, it's going to become 5 and 1 because the common factor here that both of these numbers are divisible by is 7. So 7 divided by 7 is 1. 35 divided by 7 is 5, just like Chloe said. How about this next one? 4 and 16. Great, Max. I see you. 4 and 16. What can we divide both 4 and 16 by to get even smaller, right? We want to simplify as much as we can so that we don't have to work with bigger numbers. Yes, it'll become 1 and 4 because we can divide by 4. Great, Chloe and Max. Beautiful. What's our final fraction going to be then in the chat? What is our final fraction going to be? We have 5 times 1 in the numerator now, and in the denominator we have 1 times 4 to get 5. Great, Chloe. 5 over... Great, Max. 5 over 4. Beautiful work. Now, take a look back at this. Take a look back a couple steps. What if... Chloe, amazing. I love it. Improper fraction. 5 over 4 can be rewritten as 1 and 1 over 4. I love that we're learning. We're bringing everything together. Love that. What if we just did 12 times 35 at first? That would have been crazy. That would have been 420 all over 21 times 16. What is that even? That's 126 plus 210. So that'll be 336. Is this what we want to work with? No, we don't want to work with bigger numbers like this. Instead, we can use this trick, this method, in order to simplify as much as we can before we get to our final answer. Great job. Right, 420 over 336. So there are going to be a lot more steps than we just did, right? We might need a calculator as well. So that's why we're learning it this way. Hopefully you're learning something new today. Now, we just talked about multiplying, so we have to talk about dividing as well, because multiplication and division are inverses, and it's always great to group them together so that we can put it in the same category in our brains. Does division work the same as multiplication? Well, let's try it out. 8 over 24 divided by 4/3. Well, learning from our multiplication, how about we just divide straight across? What if we have 8 divided by 4 all over 24 divided by 3? Well, what's 8 divided by 4? Really quick in the chat. What's 8 divided by 4? And then tell me right after the denominator, what's 24 divided by 3? 2, right? Yeah, 2 all over 24 divided by 3. Great, Max. Great, Chloe. Is 8, right? 24 divided by 3 is 8. Now, great, Max. 2 over 8. 2 and 8 have a common factor of 2. So what would our final fraction be here? If we simplified 2 over 8 completely, what would our final fraction be? 2 and 8 have a common factor of 2. I know, Max, you guys are going back and forth. I love it. It's going to be 1 over 4 because 2 and 8 both have a common factor of 2, and we can divide those, cancel those out to get 1 over 4. Beautiful work. Now, let's take a look at this one. We have 5 divided by 3 and then 6 divided by 10. Can we do these and get a whole number after? This one looks a little tougher, right? This one looks a little tougher. So now let me ask you a question. If I ask you to divide a number by 2, right? Let's say I have this number and I want to divide it by 2. What is another way? I know it doesn't work, right? What's another way we can rewrite dividing by 2? Maybe as multiplication, because we just talked about division. Or we just talked about multiplication. Dividing by 2. Think back to our chocolate example. When we have something, what are we actually doing? If we're dividing by 2, then we can multiply by. When we're dividing by 2, it's the same thing as having something. And so it's the same thing as, it's like 1/2. Exactly, right? Multiplying by 1/2. So if we have another number and we're dividing by 5, then this is the same thing as multiplying by. Well, let's take a look at this previous example. I know this one's a little tougher, right? We have to think about it a little more. When we divide something into 2 pieces, that's the same thing as multiplying by 1/2 because we're having it. But check this out. Any number can be written over 1. If we divide into 5 pieces, then that's the same thing as multiplying by. Great, Chloe. We're using critical thinking. We're using context clues here. We're simply flipping, right? We're simply flipping the number that we're dividing by and multiplying by that number flipped. Okay? So let's check another one. And I want both of you to answer this one. If we're dividing by, let's say, 3/2, what would I be multiplying by here? Take a guess. If we're dividing by 3/2, this would be the same thing as multiplying the same number by, yeah, which one do we flip, right? So far, which one have we been flipping? We've been flipping the one that we're dividing by, right? Our divisor. So we're dividing by 3/2. So Max, you are correct. We're going to multiply by 2/3, right? Great, Chloe. I love that we're getting this. It was really difficult to think about this at first, but as we notice the pattern, right? Math is the study of patterns. As we notice the pattern, we get better and better at this. Yes, yes. Time to celebrate. Amazing. Now, so we go back to this problem. We don't want to do this because 5 divided by 3, we don't really want to deal with that. So instead, we're going to change this into multiplication. We're going to say, all right, 5, 6 stays the same, right? That beginning number will stay the same, and we are going to flip the second number that we're actually dividing by and multiply by it. So times 10 over 3. Yes, so we don't flip the left side because think about it. If you have 4 and you're dividing 4 into 2 pieces, each piece will give you 2, correct? So this is 4 times a 1/2, and that's equal to 2. But what if we flip the other one, right? If we flipped 4, that would give us 1/4 times 2, and that'll give us 1/2, which wouldn't work, right? Yes, exactly. And now, once we have this multiplying these fractions, we would get 5 times 10 all over 6 times 3. Well, 5 and 6 have nothing in common. 10 and 3 have nothing in common. But now we can switch 5 times 10 into 10 times 5. This is also called the commutative property of multiplication. You may have heard of that before. And we know 10 and 6 have something in common. They're both even. So what can we divide both 10 and 6 by? In the chat. 10 and 6. We can divide both 10 and 6 by? Oh, let's focus here, Max. 10 and 6, we can divide by 2. Great, Max. By 2, we get 5 and 3. So 5 times 5 is 25. 3 times 3 is 9. And that's our final answer. Amazing work. All right, well, we have a couple more slides left here, so stay with me. We're going to practice these. And guess what? What's back? Mixed numbers are back, right? Mixed numbers are back from our accessing prior knowledge from our APK. Let's take a look. Simplify the following fractions. What's the first thing you would do here in part A? We have 4/5 divided by 2/7. What's the first thing you would do here? I'm going to rewrite this. Divided by 2/7. From our previous slide, having learned something new on our previous slide, what's the first step here? 4 divided by 5, or sorry, 4/5 divided by 2/7. What's the first step that we want to take here to make this problem easier for us? Exactly, Chloe. We want to flip, right? We want to flip the fraction that we're dividing by. So we have 4/5 times 7/2. And now we can cancel out 4 and 2. Yes, great. We're going to level up a little bit here. And instead of having to switch, we now know that since multiplication is commutative, we can cancel out whatever is in the numerator that's being multiplied with any number that's being multiplied in the denominator. As long as both operations are multiplication, we can cancel. So 4 and 2 have a common factor of 2, like Chloe told us. We can cancel out a 2. We have a 2 and a 1 down here. 7 and 5 have nothing in common. 2 and 5 have no factors in common. So this is completely simplified. 2 times 7 gives us 14, and 5 times 1 gives us 5. Okay, now we have letter B. We've never seen something like this before. Great, Chloe, 14/5. We've never seen something like this before, but we do know from our APK we can rewrite this in some form. Max, great. Chloe, I love that we're using mixed numbers as well. Let's write it as a mixed number as well. Amazing work. For letter B, how can we rewrite this to make this look more familiar so that we can actually solve it with our methods for dividing fractions? What's the first step you would take here? Because right now it's not in a not written in a way that we're comfortable with, really, that we've worked with so far. These are both mixed numbers, so maybe we can rewrite them as maybe improper fractions. And in that case, what would my improper fractions be for these two fractions? What would my two improper fractions be? Make it into imperfect fractions. I love that you used imperfect. The name for this is improper, but I can see why you would say imperfect. Max, great. 7/3 will be the first improper fraction, right? 2 times 3 wholes will be 2 times 3, which is 6, plus that 1 on top gives us 7/3. Awesome. Divided by, and it looks like, Max, you gave us that second one as well. 1 times 5 is 5, plus the 2 will give us 7. We have 7/5. Knowing that now we can solve this out, if we divide by 7/5, what's another way we can rewrite this so that it's more comfortable for us? Because right now, if we wrote this straight across, it'd be 7 divided by 7, which we know is 1, but 3 divided by 5 can make us a little uncomfortable. So instead, what we do, Chloe, exactly, we flip the fraction we're dividing by. So we have 7 divided by 3, or 7 over 3, times the flipped version of 7 over 5, which is 5 over 7. We're going to write this across one last time before I show you another trick. 7 and 7 cancel out, and we're left with, what's our final answer? Exactly, Chloe, the 7's canceled out. And our final answer, what are we left with? And give it to me in both improper fraction form and mixed number form. Give it to me in both forms. Great. Remember, when we multiply fractions, we multiply straight across the top and straight across the bottom. We multiply the numerators, multiply the denominators. So 1 times 5 gives us 5, and 3 times 1 gives us 3. And I see both Chloe and Max, amazing work. We put it into mixed number form as well, 1 and 2/3. Great work, y'all, great work. Let's keep it going with letter C. How would we rewrite this one to get us started? Let me know what the improper fraction for that first fraction is. I'm confident that you guys can get this now. 3 1/4, how can we rewrite that as an improper fraction in the chat? 3 1/4 as an improper fraction. We know we have 3 wholes. We know that each whole right now can be divided into 4 pieces. So we have 3 times 4, which is 12, plus the 1. Love it, Chloe and Max. Both of you got it. 13/4 divided by 2. Now, here's where it might get a little tricky. We have 13/4, and I want to rewrite this as a multiplication. How can I rewrite this as multiplication? Right now, we're dividing by 2. That means we can multiply by what fraction? If we divide by 2, if we divide something into 2 pieces, that's the same thing as having the original whatever fraction we have. And yes, Chloe, you're correct, times 1/2. And notice, 1 doesn't have anything in common with 2. 13 and 2 don't have common factors as well. So this time, we're just going to multiply straight across. So let me know in the chat what you get as an answer for this problem in both improper fraction form and mixed number form. Let me know in the chat. I'll give you a couple seconds here. We know that we can multiply straight across the numerator, straight across the denominator. Chloe gave us that improper fraction first. Yes, 13 times 1 is 13. 14 times 2 is 8. And in mixed number form, 8 goes into 13 fully 1 full time, leaving us with 5 extra pieces, 5/8. Amazing work. Can you believe that we've gotten this far after talking about just chocolate and improper and mixed numbers at the very beginning? Can you believe we've gotten this far, right? Amazing work. Now, let's apply it to an actual question, to an actual application problem. Yes, great participation. Now, Lucas spends 1 2/3 minutes reading each page of his favorite book. Okay? Lucas spends 1 2/3 minutes reading each page of his favorite book. How many pages can he read in 30 minutes? It's really easy now. Great, Chloe. Love how we're growing through this one lesson, right? How many pages can he read in 30 minutes if he spends 1 2/3 minutes reading each page of his favorite book? What can we do here? Let's think about this for a second. 1 2/3 minutes for each page. I want to find out how many total pages Lucas will read in just 30 minutes. Around 30? Well, that's a good guess. How did you get there, Max? Is it because you saw the 1 minute here? And you said, okay, well, we have 30 minutes, so maybe 30 divided by 1 will be 30. Is that where we got that from? 5/3 times 1/30. Ooh, let's write that down as well. So 30, around 30 is a good guess. We have 5/3, which we got as an improper fraction from the mixed number 1 2/3 times 1/30. Well, this would become, well, 5 and 30 have a common factor of 1. So now we have 1/18. Does that make sense? Does it make sense that if Lucas spends 1 and 2/3 minutes reading each page, in 30 minutes he's only read 1/18 of a page? Okay, we're getting somewhere. We're taking out all the possibilities, right? We're checking all the possibilities because the 30 times 1 is 30. Yes, okay, that's exactly what I thought you were going to say, Max. That's great. That's a great guess. So this time 1/18 might not work. Oh, okay, Chloe, you said 5/3 times 30. Let's try that instead. 5/3 times 30/1. Well, 3 and 30 have a common factor of 3. So what would be my final answer here? What would be my final answer here? 3 and 30 have a common factor of 3. So when I cancel these out, 3 divided by 3 is 1. 30 divided by 3 is 10. So now I have 50. But remember, I see you said 50, correct. 50 is correct. But Chloe, we're asked for how many pages? So 50 pages. Now let's think about if that makes sense, right? If it takes more than a minute to read each page, and Lucas was given 30 minutes, does it make sense that he read 50 pages in 30 minutes? Hey, all good, right? We're canceling out the ways, right? We're taking all the possibilities and eliminating the ways that this might not work. So let's think about it a little more, right? After 1 and 2/3 of a minute, how many pages has Lucas read? After 1 and 2/3 minutes, how many pages has Lucas read? I know, yeah, we're getting lost for a second here, so I'm bringing us back. Lucas spends 1 and 2/3 minutes reading each page of his favorite book. So after 1 and 2/3 minutes, he's read 1 page. Correct. Amazing. We're getting somewhere. Now, after another 1 and 2/3 minutes, how many pages has Lucas read? Yes, because of the fraction, this is getting a little confusing, right? So after 2 iterations of this, 1 and 2/3 plus another 1 and 2/3, yes, now we've read 2 pages. Okay, now what if we kept adding 1 and 2/3 until we got to 30 minutes? Now let's think about this, right? How many times do we need 1 and 2/3 minutes to get to 30? If we answer that question, do you believe that we'll get to the total number of pages? How many times does 1 and 2/3 go into 30? How can we write that as an expression? How many times does 1 and 2/3 go into 30 minutes? How many times does 1 and 2/3 minutes takes us to 30 minutes? 50 over 5/3. Again, we don't really need the 50 here anymore because we know that's out of the question, right? But good guess. We're getting somewhere. 30 times out of, okay, we're getting somewhere. So what if we have 30 as a whole, right? We want to find out how many times does this 1 and 2/3 go into the whole of 30? Can we do 30 divided by 1 and 2/3? Right? We're dividing this 30 into how many times does 1 and 2/3 go into 30? And I like how you're guessing a number less than 30 now, Max. But let's see where this gets us, right? Because we know that every page takes more than a minute, so it makes sense that the number of pages Lucas can read in 30 minutes will be less than 30, right? Exactly, Chloe. 30 divided by 1 and 2/3. Now, how can we rewrite this? We can rewrite this as 30 divided by, what's the improper fraction we can work with? Because right now, 1 and 2/3 is in the form of a mixed number. I want to rewrite this as an improper fraction. 1 and 2/3, as we found earlier, can be rewritten as 5/3. And I see, Chloe, you're ahead of the game now. We have 30 times the flipped version of 5/3, which is 3/5. Now, I want to multiply across the numerator and across the denominator, but I don't see a denominator for 30. What's actually under the 30 here in the chat? Everyone, what's actually under the 30 here that we just don't write because it's kind of invisible? Because 30 is a whole number. Exactly. Great, Max. Great, Chloe. I love it. We remember 30 can be rewritten as 30 over 1. So now we can multiply across 30 and 5 have a common factor of, what are both 30 and 5 divisible by here? So we can simplify before we get to the final fraction here. 30 and 5 are both divisible by 5, right? 5 divided, sorry, this might have looked like a 6 because I canceled out already. I got you, Chloe. Great, Max. 5 divided by 5 is 1. 30 divided by 5 is 6. So now we have 6 times 3 over 1 times 1, and we have 18. Yes, 30 is now 6. Oh, that's what you meant. Thank you for clarifying, Chloe. That makes perfect sense. You were correct about that. So 18 pages is how many pages, is the number of pages Lucas read in the span of 30 minutes, because he reads one page every 1 2/3 of a minute. And that's our answer, 18 pages. And we got there, right? It took us some time, right? It took us some patience, but we got there eventually. That's what matters. Growth mindset, right? Growth mindset. Okay, well, I believe that concludes our lesson for today. But before we end, how do I change to... there we go. If you enjoyed I know we almost gave up. If you enjoyed the lesson, put a plus in the chat, so I know that you're still here. If you enjoyed today's lesson, put a plus in the chat. Hopefully you enjoyed it enough. And while you put that plus in the chat, your brain hurts a little, well, we learned so much in an hour, right? An hour is already gone. Call your parents over, call your guardian over, or whoever adult is over. And don't worry, if you missed this lesson, it's been recorded. You can always come back to this later on as well. All right, I have something really special to share with you today. Our lesson may be ending, but your progress does not have to. My EddSpace, the grade 6 through 8 math full year course, will start on October 6th. So just over a month from now, our full year course will start. Each course will include 2 engaging live and interactive lessons each week. So our course, grade 6 through 8 math, will meet Mondays and Wednesdays, 5 to 6 p.m. Great, Max. I love the enthusiasm. We'll meet 5 to 6 p.m. Pacific time every Monday and Wednesday starting on October 6th, and it's going to look exactly like what you saw today. Live, interactive with the chat, and you can ask questions and learn along the way. Not only that, every lesson will be recorded. So let's say you missed a lesson because maybe there was a lot of traffic, maybe you had extracurricular activities. Everything is recorded so you can revisit them. Also, if you're ever studying for an exam later in the future in school and you're like, oh, I remember learning this with Eddie, let's go back to that lesson. You can do that as well, right? All these lessons are recorded. Professionally designed workbooks, hopefully you were able to access them. They're in the video description link. You'll get professionally designed workbooks for every single lesson. Practice with exam style questions. Now, you don't get that today, but if you join my course, you'll get practice problems after every single lesson that are exam style questions to prepare you for your classes in school as well, for your exams in school. And with those practice problems, you'll get detailed video solutions made by me. Right? Aren't you tired of looking at the back of a textbook and you just see an answer, or you just see the solution written down there, right? Oftentimes, we don't even know what's going on in those solutions. Instead, with me, you'll get detailed video solutions where I solve out every single exam-style practice problem you get so that you know exactly how they're done. But how much is it? Let me have you guess first. When I used to be a private tutor, how much do you think I would charge per hour? In the chat. How much do you think I would charge per hour here? Each hour for each student as a private tutor, guess how much you think I would charge? Chloe, you've been here, so you already know. 45, 100. I used to charge a minimum of $100 per hour. And for students that were really cramming and getting ready for exams and things like that, up to $200 an hour. So the thing with this is that families always have to choose between what works and what they can afford. How much can they afford and how effective are they? You can never find both in a tutor. And that's why we created My EddSpace. You get all of this, right? 2 lessons, live lessons each week, video recordings, professionally designed workbooks, practice problems, detailed video solutions, insane value, all that for just $99 a month. $99 a month for 6 to 8 lessons per month. 8 times cheaper than what I was charging as a private tutor. But why stop there? Because you're here today. Because you are here today, you get 20% additional discount on our annual package. Let me do the math for you really quick. Our course starts on October 6th, goes all the way through the month of May. So it's like a full school year. And so that totals to 60 live lessons, right? Over 8 months. If you have 8 months times the 99, that's around $792. Great value still, right? That's like 8 private sessions with me. But with 20% additional discount, because you're here, all the spots are limited, it'll only be $649. And to protect you from any risks, we provide a 30-day risk-free full refund guarantee. It's a first come, first served basis, and this is a limited time special offer. So if you're interested in either the monthly installments or the annual package, the huge discount you'd be getting, text the code word START to my number on the bottom of this screen, or scan this QR code, or take a screenshot of this to show your parents later. Take a screenshot of this, scan the QR code. If you scan the QR code, you'll be prompted to text the code word START straight to my number, and we can get talking, right? If you enjoyed today's lesson, if you want to continue to learn with me, if you feel like this type of learning will get you, ahead of all your classmates, get you A's on all your tests, just make math fun again, right? Text that code word START to this number, and we can get you started. Yes, take that screenshot. You can always come back to this recording as well. You can always come back to this recording. Take a look at all of this again, right? But to get you started, text that code word START to this number. You can do it yourself, and we can get talking, right? Hope you enjoyed today's lesson. Yes, Max, if you really need something like this, I mean, take a screenshot. I don't know if your parents are next to you. Maybe this could be, a gift for you for this school year. I mean, I guarantee it, you're going to be ahead of all your classmates. You're just going to be acing every test. You're going to be, like answering questions in class again, right? Raising your hand, answering questions, helping your peers. And that's when you really know you're getting better at this, right? You're loving math. You're having fun in math class. And that's what this is all about, right? I have the full year course already created, ready for you, planned for you. So text that code word START to this number, and we can get you started on your journey with me at my EddSpace. Right? Actually focusing in an online lesson, right? This is why I'm here, right? I used to charge $100 an hour, great value, but now I'm here with my EddSpace. I partnered with my EddSpace to make this accessible, fun, affordable for all students across the nation. So because actually focusing online lesson, amazing, but it's not including my entire year of grades because I just started. Exactly, Max. But again, you're going to be at the top of your class after taking my course. And by the way, these lessons are going to be kind of following along with what you're learning in your course. But because my course starts a little later, it could reinforce your skills that you already learned. Furthermore, not only reinforce, but fill the gaps, right? Maybe your teacher didn't cover something as well as I will, right? Which is honestly high probability. And again, since we're meeting twice a week for 1 full hour, you'll get ahead of your class eventually, right? I know we have a later start, not that late to be honest. It's only a month, but you're going to catch up and you're even going to get ahead with this course. Yes, you're going to have an S, exactly, S tier, right? So go ahead, make sure you have this screenshotted, make sure you text that code word START to this number, to my number, and then we'll get talking. Thank you so much, everyone. Thank you, Max. Thank you, Chloe. Thank you, George. Thank you, Raymond. Thank you, everyone, for your time. W's in the chat, and I'll see you all in text soon. We'll text soon, all right? Thank you, everyone. Have a great rest of your evening. W's in the chat. W. See y'all. Thank you all. Bye.